Okay, here we go. Chapter 3 test review, chapter 3. Test review. I'll take some notes. Very first 3 questions, the instructions are, if you want to write anything down, it says, solve each equation. Round decimal answers to the nearest hundredth. How are you going to tackle that? Every equation is quadratic because that's the name of the chapter. Yeah. How are you going to do that? 3 questions that say, solve each equation. Round decimal answers to the nearest hundredth. What do your instincts tell you? Yeah, that'll work, except for that won't give you decimals. Graph it. Of course, graph it. If you're allowed to round to the nearest anything, decimal-wise, calculator's your best buddy because that's how it answers everything. The only problem with these 3 things is that they're not ready to be graphed. They're not ready to go, which means you got to do a little bit of algebraic manipulation. My suggestion in every case is to get things on the side where the squared term is positive. Then graph it and ask the calc key what the zeros are. Remember how to handle that? Yeah. We're going to do one like this, and that's all. Are you ready? So it's going to be something like this, and they may not have x as the variable, but as you know, you type x when you do it in the calculator. So if I have something like this, 2y squared minus 11y equals 5y plus 122. I just made this up, so I have no idea how it's going to work out. So it says round to the nearest hundredth, which means you're going to grab this guy, go to your y equals screen, clear it out, make sure the plots are off. I'm sure they are by now. And I'm going to type in, we're not ready to type something in, see? And so if you want to show me your work on this before you actually come up with an answer, because see what happens is, I grab the answer sheet. I grab the answer sheet and I grade it. And if they're right, I give you full credit. If it says to answer it a certain way, I go and look for your work to make sure that you answer it the way I told you. But for this one, it's just to the nearest hundredth. So I will look at those, and if they're correct to the nearest hundredth, I move on. But if they're wrong, I go to look for your work. And if there's nothing to show me because you did it all in your calculator, then you miss it all if you miss it. So what I'm saying is this. On your paper, it would be really wise of you if you were given this to show me what you intended to bring over. Sometimes what people do is they have a negative 11 here and a 5 here, and they think they should add that. They get a negative 6 here, which is going to cause you to get the wrong answer. But I can forgive you for that, not entirely, but it will cost you everything. If I can see that you made an arithmetic error moving things over, and so you graphed the wrong equation, then I can graph that equation and see if you got the zeros for that one. Because if so, that was just an arithmetic error, and it doesn't cost you very much. But if you can't show me anything and you miss it all. All right. So that's the first move. You should show me that. Then you should graph it, being very careful to type it properly, because if you get this part right and you get the answers wrong, then it costs you about half the problem, because I can't tell why, because I can't see your calculator. So type it carefully. So we're going to go 2x squared minus 16x minus 122. And I would start on a standard screen and see if you can see it. That's what you get when you graph it, which means you can only see one x crossing. But because you know the behavior of graphs, folks, you can see that thing's leaning this way, which means it went way down here and came back up, and when it came back up, it was beyond the screen. Does that make good sense? Yeah. So let's extend the y's out. Go to your window and change maybe the, what was it we need to extend out? The x's or the y's? The x's, how far should we go out? Right now it's set at 10. How far do you want to look out? 20? You want to try 20? Okay. So you would change the window like that so that you can see farther out. Oh, there it is. So sometimes, folks, when you're allowed to use your calculator to do things, Not everything you need is going to show up in a standard window, and you have to know, because you're using a calculator, how to adjust it. So I'm going to go after this leftmost 0 first. I'm going to go second calc 0. I'm going to try that again. Second calc 0. Now, here's one thing to remember about your calculator. When your crossings, or the lines that are crossing, the things that are crossing, pieces of parabola that are crossing, are really, really vertical, sometimes moving that cursor around isn't a good idea because you'll miss it. It'll go from the top of the screen above where you can't see it down below. So when that's the case, you should count your little tick marks. So when it asks you for a left bound, I'm looking at the left 0, and I'm going to go out 1, 2, 3, 4, 5, 6. -6 is to the left of it. -4 is to the right of it. So I'm going to type those in instead of use my cursor. And I get -4.77 when you round it to the nearest. I get -4.77. And I'm going to go find the other 0. Calc a 0. And I'm going to count this one too, except for that's going to take me a little bit of effort here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I guess between 12 and 14. So I'm going to say a left bound is 12 and a right bound is 14. And hit enter, and it goes to 12.77. That's what you put in the answer blank. And because you're allowed to have the calculator do all the work for you, you had better have a good sense of how to round to the nearest hundredth, because that will be part of the points that you get, is whether you can round properly or not. That was really close. It was 12.7749, but that 49 is not enough to boot that 7 up. If it had been 0.5, just one more 10,000th up, then it would have been 7.8. So you'd better be able to round properly for full credit as well, since this is doing most of the work for you. Okay, so that's what the first 3 are about. And I will tell you this, on the first 3 problems, all of the answers are real. So you will get either 1 or 2 crossings of the x-axis, and you find them. Okay? Are we clear? All right. The next set of exercises, next set of problems are from 4 through 10. So there's 7 of them. And here are the instructions. It says solve each equation. Answer in simplest radical form. So what that means is you're going to have to show your work on these. And there are 3 or 4 different types of things that you're going to have to handle. So I'm going to show you one of each. Stay with me here. Perhaps you can follow this and you'll go, oh yeah, I can handle it. That's not a big deal. The very first problem, number 4, looks something like this. And the instructions are solve the equation, answer in simplest radical form. It's the first thing you should do. Okay, so which side do you mean? From left to right. So we're going to put the 0 on the left?
Yes. Yeah.
Why did you make that choice? Because x squared is positive on the other side.
Yeah.
Yep. Yeah. Okay. So we're going to have 0 equals, and when you write this down, write it down in order. As you bring it over and put everything together. Okay? So that's the first move you should make, so that if you have to use the quadratic formula because it will or will not factor, I mean, you don't want to make that decision. Numbers are too big and you don't want to take time to decide. You want to be able to clearly identify A, B, and C with the correct signs. I don't want to wonder if this thing's going to factor. I know I can't take a 2 out of everything because 35 is odd. And these numbers are too big for me to consider factoring. I'm not even going to look at it. So I'm going to jump right to the quadratic. And so you should write on your work, you should do this, and then you should write x equals the opposite of b plus or minus the square root of, and I don't know what 35 squared is. I know up quite a ways, but not that far. 35 squared is 1225. 1225 minus 4 times AC would be 208. All over 4. Based on what you're seeing right here, do you think we'll get positive or negative answers? Real or imaginary answers? Real, because this difference is still going to be positive, right? All right, so I'm going to work that out because those numbers are awful big. So I'm going to take the 1225 and subtract 4 times 208, which is 393. That's pretty gross. 35 plus or minus the square root of 393 over 4. Now, I've got to simplify as much as possible because it says simplest radical form, which means I've got to simplify this if I can. So I'm going to go over here on a little piece of scratch paper over here to the side. I don't care where. It could be really close to this. I know what you're going to be doing, so you should put 393. And 2 won't go into it. Will 3? 3 will. So I'm going to put a 3 in there. That's going to be a 1 and a 3 and a 1. Is that right? That 131, that looks... I don't know what that... I'm going to try to divide it by something. 131, 2 won't go into it, 3 won't go into it because 1, 3, and 1 is 5, which 3 won't go into. 5 won't go into it. Will 7? Will 11? Will 13? Then it's prime. How can I stop there? I mean, shouldn't I check every prime number clear up to 131? No. You'll have to check every prime number up to the square root of 131 to check it all out. And I've already passed that because 131 is between 11 and 12, and I've already checked out 13. So it factors into 2 prime numbers. There's no pairs, nothing comes out. So this is it. Simplest radical form. I'm not saying it will be the numbers that big or that ugly or that nasty, but I'm just saying this is the process you go through to solve this thing in simplest radical form. If something had come out of here, it still would not cancel, would not simplify, although I would still expect the radical to be simplified. I know it won't simplify because 4 won't go to 35. So even if 4 would go into this, or there was some common factor there, I couldn't take it out of everything. So even if the something pulled out of here would not simplify any further than pulling that out. Just saying. A lot of weird things you have to consider when simplifying. But we ended up with 2 prime numbers, so we leave it. Okay, the other type of problem amongst these 7 is like this. Say something like this. Negative 5x squared minus 25 equals 0. This is quadratic, but it's of a special type because there's no x term. You have to be able to recognize that and say, oh yeah, there's no x term, which means I can solve for x squared algebraically. I don't need the quadratic formula. You could use the quadratic formula, although you're opening yourselves up for all kind of errors because there's no b term, and so your b's will end up being 0, and sometimes that's difficult for people to deal with. Happily, since the b term is missing, you don't need it. You just isolate this term, then isolate this term, then square root. So we get negative 5x squared equals 25. We divide that by negative 5. We get negative 5 over here. And we square root, we get x equals plus or minus, because you're square rooting in the process of solving. You're square rooting a negative, so there's an I, and root 5 doesn't come out. Done. A lot of math going from here to here. You have to remember your plus minus. You have to remember the square root of the negative is actually imaginary, and that 5 is prime, so he has to stay inside. Everybody clear or not? Okay, so there's that type. There's also another extracting square roots type, like this. Hang on, I gotta find that page. Oh, I know what happened. Okay, like this, something like this. 2 times x plus 4 squared minus 6 equals 28. Something like that. And that doesn't quite feel like the one we had just a minute ago, but the only difference is that the one we had before was just x squared, and now I have a couple of terms in a binomial squared. The first one was a monomial squared. This is a binomial. It's handled exactly the same way. You have to isolate this, doing the algebra, pretending this is just a single thought and a single notion. We've got to isolate this, and then square root, and then get rid of the 4. So to isolate this part that's squared, I got to first get rid of that 6. Does that make good sense algebraically? So I'm going to have 2 times x plus 4 squared equals, you got to add the 6 to the other side, which makes it 34. Then we divide by 2 because it's not being squared, and I'm trying to isolate the squared part. So I have x plus 4 squared equals 17. Now I got to handle that, get rid of that by doing its inverse, which is square rooting, and I get x plus 4 equals plus or minus, can't forget that, square root of 17. And then we toss the 4 over to isolate the x. I mean, negative, it's customary to put the negative 4 here so the plus minus can be in between. So we just tuck it in right there. Simplest radical form. There it is. It's a extract square roots problem. Even though the thing being squared is not a single x value, it is a binomial. Still, we handle it the same way. Isolate that algebraically, square root, don't forget your plus minus, and then ultimately solve for x by getting rid of whatever's with after you peel that off. Okay? Good. Trying to decide if there's any other kinds. Yes, there's one other type. So all of these have to be handled on your pencil with pencil and paper on your test. You should show me your work. Something like this: 2x times x minus 3 equals negative 10. This doesn't look like it's quadratic, but it is as soon as you do what? Distribute. Very good. That's how we're going to start this one. We get 2x squared minus 6x equals negative 10. Now it looks an awful lot like the first one I did for you, now that we've distributed. So you observe that this is the positive x squared, so the 10 should come over here. 2x squared minus 6x plus 10 equals 0. These numbers are small enough. I might want to consider factoring. I'm not sure I will, but I want to consider because the numbers are small enough to deal with. First of all, notice that there's a 2 that can come out. You should always do that because anytime you can deal with smaller numbers, you make fewer mistakes. So now I'm looking at this and I'm asking, are there factors of 5 that add up to 3? There is not. There's only 2 factors of 5, and that's 5 and 1, and they add up to 6. So this won't factor, but considering it for a moment might have helped shorten the problem a little bit, but it doesn't work. So I am going to apply the quadratic formula only to this. Can anybody tell me what becomes of the 2? And the answer is it is irrelevant in determining any answers because this will never be 0. See, we're saying 2 times this junk equals 0. Which one of them 0? It has to be in here. This is irrelevant. He'll never be 0. He's stuck at 2, so we can ignore it. You understand what I'm saying? And by factoring it out, I've cut down the size of the numbers when I use the quadratic formula, which means I'll probably make fewer mistakes. So I'm focused on this remaining quadratic, and I am ignoring that because it's no longer relevant. So here we go. We would say x equals the opposite of b, which is 3, plus or minus the square root of b squared, which is 9, minus 4 times ac, which is 5, over 2. I'm ignoring this and the entire application of the quadratic formula there. Are we going to get real or imaginary solutions?
Real.
Imaginary. It's going to be 3 plus or minus. This has to be done first. This is negative 20. Combined with a 9 is negative 11. Gross. And 11 is a prime number. That's a happy thing because I don't have to simplify anything. So it's going to be 3 plus or minus I root 11 over 2. And 2 doesn't go into those, so we are finished. If you want to be super proper about it, like some other professors and teachers might require you to do, then you could go one step further and put the 2 under both, which would be 3 halves plus or minus the square root of 11 over 2 I, because now it's BI form, But for me, as your teacher, I will accept either one. Doesn't matter.
Ms. Johnson,
Yes.
would you excuse Kelly Cox? She needs to leave. Thank
Okay.
you.
All right.
Have her come by the office.
Okay.
Check out.
All right. You can check out this video for the rest of this review, okay? All right. Okay, so those are all the types of those problems. There's 7 problems from 4 to 10. That's a sample. You've seen a sample of every type. So if you handle those and you looked at those and goes, that's exactly what I would have done and I know what I'm doing, then you don't need to write anything down. But if you didn't, you might want to study that type and make sure that you're aware of it. Okay. The next set of instructions, there are 3 problems under these instructions, and all it says, just 3 little words. Solve the system. It does not say that the solution has to be in a certain form, or that you have to round to a certain number of decimal places, or anything. It says, solve the system. And that means there's going to be 2 equations for each. There might be 2 parabolas, there might be a parabola and a line, there might be a line and a circle. That's what we mean by a system. There's 2. And it says solve the system. What's your instinct tell you to do? Graph it and find intercepts between the 2 graphs. Find where they hit each other. That's number 5 on your calculus, right? The only hang up there may be is that the equations that are given to you may not be set up and ready to graph. Both of them might not say y equals something. Instead, it might have it all messed up, and you're going to have to solve for y before you can enter it in your calculator. That's the part that's got to come from your brain. If not, like there's one on here at least that looks like this: y equals 2x squared plus 6x minus 11, we'll say. And the other one is y equals something like negative 2x plus 1. So that's a parabola and a line. And it's offered to you like this, which means it is ready to go. There's nothing for you to show. So you'll either get it right or you won't, which means better enter in your calculator very carefully. So 2x squared plus 6x minus 11 and negative 2x plus 1. Go back to a standard screen because we augmented the last one. So go back to a standard screen.
Oh, dang.
Okay, so this is the kind of thing you get if you graph it in a standard screen. And you can clearly see one of the intersects, right? The other one isn't quite clear. It looks like it's going to hit it. Surely it's going to hit it. But we can't see it in the screen. What do we got to do? Yeah. Go up a little ways on the y's. What do you want to make the y max equal to? 15. Okay. Graph it again. And see if you can see it. I bet you can because it was awful close with a 10. Yep. See it right there? You can see both those intersects. Go find them. So we go second and the cal key and intersect, which is number 5. Get the cursor closer to one or the other intersects. I like the left one first. That's what I always go for. And then just hit enter, enter, enter. And the result is irrational, but that's okay because it didn't say it had to be in any particular form. So if this was number 11, we'll pretend that's the very first one. And then on the answer sheet, it says number 11, and it will have this, reminding you that we want whole points, not just the x values, but the points. And this very first one, the one that was up there a little ways that we had to find, is negative 5.16. Why did I choose hundredths? Because it's always a good default. It didn't tell you how much. If you chose negative 5.2, I'd still give you credit. Or if you chose negative 5.1623, I'd give you fun. It would be fine. Because it doesn't tell you. Just so long as you're really, really close to the answer. I would round to at least 1 decimal place. So this is 0.32. Now I got to go find the other one. Second calc and intersect. Get it closer to that one now. With your navigation arrows. Enter, enter, enter. And we get 1.16. and negative 1.32. Do you remember what I told you to do if you find that this line just snugs by the parabola in one place? Remember what I told you to do? You put that point of intersection in the first one and you cross this one out, indicating to me that you know there's not another one. Remember? Mm-hmm. Now, if you get something like this, if I change this just a little bit, no, you change this a lot bit. Let me make this a 1 here instead and make this a negative 8, something like that. Why don't you graph those two now that I've fixed it, that I've adjusted it. Graph those two. 2x squared plus 6x minus just plain old 1. So just sit on the second one of your 11 and hit delete. And then negative 2x, you have to change that to minus 8. See what we get there. Oh, that's not quite what I wanted. Make this just negative x. Go back and fix it. Can you see, even in the Zoom screen, that it's really close, but it does not hit it? Yeah. What do you write then? No. Like this. It's gonna. Your answer is going to look like this. It's going to have commas in here, and you write all over the top of it, so that I know that you know that these shouldn't have anything in them. Don't just leave it blank. Everybody clear on that? If that happens and they don't hit, first of all, make sure that you entered them properly. They go back. If they don't hit, go back and make sure you entered them right. And if you've entered them right, then that's what you would write. 3 problems like that. Oh, at least one of them is like this, where it's presented to you, not solved for y, but it's pretty easy. Just let me show you. If something like this, 3x minus y equals negative 4, and negative x squared plus 3x minus, or plus, let me make it minus y, equals 8. That's not ready to graph. You're going to have to do some work. To get this one ready to graph, we have to solve for y, and it can't be negative y. It has to be y. So I would do this. I would say 3x plus 4 equals y. Tossing these two around. Getting y by itself over here, and at the same time bringing 4 over here. Y'all catch that? Even though the y is on the right, you still graph this. It's no big deal. Same thing here. Negative x squared plus 3x minus 8 equals y. Now you're set to graph. Show me this in case you screw it up or get a bad sign. Then I can look at it and say, oh, yeah, it was supposed to be plus 4 and he wrote minus 4, so he got the wrong intersect points, but that's all that happened. That's why you have to show me this kind of thing on when you get things ready to go to graph. Show me what you're doing. Okay. Ready to go on? And then you graph it and do it just like we did before. Okay, so the next 2 problems. It says, find the zeros of the function. It's just a different way of saying solve the equation. It's just that in all the other cases up to this point in the test, if they wanted you to find the zeros or the solutions to the equation, it set it equal to 0. It just said this thing is equal to 0. This one says f of x is equal to this. When you find the zeros of a function, it means you're only considering the places where y is 0. So when you go to do it, you replace f of x with 0 and get it done. You know what I mean? And all it says is find the zeros of the function. Does the parabola have to hit the x-axis for it to have zeros?
Yes.
No.
Wait. Oh, this math.
If it had said find all the real zeros, then yes. Zeros means solutions. All of them, even if they're imaginary. Okay? So you may or may not run into that. When it says find the zeros, you let the function f of x or g of x or whatever it is, you set that equal to 0, and then you go about the business of solving that equation, either graphically, which is fine. If it doesn't cross, then you got to jump to the quadratic formula, expecting imaginary solutions. You know what I mean? Did you understand those words? Was I talking too fast?
Well, I mean, both things I understood.
Huh?
Yes, I'm good.
You're good.
Yeah.
We're good?
Yeah.
Okay. 2 problems like that. Do I need to demonstrate those? You just set them equal to 0 and do what I've been doing all day. Okay. Next ones, 16 and 17. 2 problems. Says simplify each expression. They're pretty easy. if you feel fairly confident with simplifying radicals by finding squares. So, show you a couple of these. One of them is sort of like this. The square root of, we'll say, 56. 56, is that a perfect square?
No.
Okay, then we got a prime factor, right? To find the squares, we have 56, and that is, anybody think of anything?
Yeah. Divided by 4 is 14.
Okay, divided by 4 is 14. Then this is 2 and 2,
Yep.
Yeah.
and
7.
7 and 2.
Yeah.
So 4 is the only thing that's going to square root. And so the answer is 2 root 14 plus or minus? Not when it says simplify and the problem is presented with a radical. It means principal square root simplified. So do not slap a plus or minus on these when they use a radical to present it. Okay, here's another type. Negative 5 square roots of negative 108. Something like that. What should we do? What? Anyone? What's the first thing you'd do?
Make a factor tree or whatever.
Good. Excellent. You make a factor tree for what?
108.
The 108. Good. 108 is not a perfect square, but at least 2 will go into it. How many times? 54. Can you think of anything that multiplies to be 54? Okay, 2 and 27 because it's even. This is not even, but what do we know goes into that? 3 and 9, and then
9 is
3 and 3.
yeah.
There's a pair of 3s, pair of 2s. What gets to come out? A 3 and a 2, and does what to what's already waiting for it? Multiply. So what we have at this point is negative 5, which is already sitting there, times that 2, times that 3. What's left? Root 3. But what did I forget? The I. Then you got to multiply that out. That's 5 times 6, which is 30. So it's negative 30. I root 3. Not plus or minus. It takes on the sign of this guy right here, because that was on the outside. It was negative to begin with, negative at the end. But it's not plus or minus. We good? That's how those are going to happen. That's how we'll take care of those. The next one, and there's only one, it's number 18. There's only one problem like this, and several of you have asked me about this already when you were working on your review. So this will be old news, but for those of you who haven't encountered it yet or never did find an answer, what it says is, find the values of x and y that satisfy the equation. Find the values of x and y that satisfy the equation, and it looks something like this. Negative 2x plus 9i equals, 24 minus 3yi, something like that. And here's the concept that they're trying to get you to understand. When you are talking about complex numbers, that is, there's a real piece of it and an imaginary piece of it. These are both in the form a plus bi. And I'm not going to change the variables, I'm just going to change the color so I can refer to them. This is a plus bi. And if you're going to get two numbers or two complex numbers like this to be equal, then the red A has to equal the blue A, doesn't it? Because if it doesn't, you can't get this side to equal this side. They have to be equal part for part. So the red A has to equal the blue A, which provides you with an equation to solve, this equation. Because the red A is negative 2x. It's sitting in the A spot. The blue A is 24. The red A and the blue A have to be equal. Gives you an equation. You solve it. The value of x must be negative 12. Does that make sense to you? Also, and it doesn't have anything to, well, it has to do with the I to put it in the right place. But it's the B's, not the BI's, just the B's here. The coefficients on I, red and blue, have to be equal, which provides you with another equation. 9 equals 3y. We leave the i's up there. That's just to say that we have to associate them because they're both I coefficients. Oh, negative 3y. So to solve that little equation that results, we're going to divide by negative 3. The negative 3 equals y. And this is what you put in the blank. Those are the values of x and y that make that complex number equal to that complex number. So you set the real parts equal and you set the imaginary coefficients equal. Okay, we all right? That's what the deal is with that. There's only one, just to see if you understand what's going on with that. Okay, and then the next set of problems, there's 3 of them, and it's to see if you remember the algebra of imaginary numbers. So, the instructions are, perform the operation. Write the answer in standard A plus BI form. Means real plus imaginary part in that form. Kinds of things you'll be up against. Something like this. 5 minus 2i minus negative 6 plus 7i. Mathematically speaking, there is no need for these parentheses, but there is these. So if you're going to show me your work, if you miss the problem and you want me to see your work, this is what you're going to write first. 5 minus 2i. Nothing's going to happen to that. But the next one's going to be plus 6 minus 7i. Because you have to distribute the negative. And then it becomes a combined like terms. I would collect the reals first since that's got to come first. And the imaginary second. And write that down. That is of the form A plus BI. Not too bad, right? Just don't forget to distribute negatives if they show up. So the operation here, when it says perform the operation, they want you to perform the subtraction and do it right by distributing. Okay, so that's one type that you'll be up against. Next one is something like this. Negative 4 plus negative 12 minus 3i minus 6i. Something like that. And that's not too hard, especially if this is a plus sign, because there's no need for these, and it becomes a combining like terms immediately. And so you get negative 16 and negative 9. But there is a problem if this is a minus sign here. Now you've got a little bit to do first, just like the last one. It's going to be negative 4, and then plus 12, plus 3i, minus 6i. And now you combine like terms. That's going to be 8 this time, and this is going to be negative 3i. So sometimes you have to distribute, sometimes you don't. It depends on what's sitting out here. Plus signs don't get distributed. Okay, moving on. The other problem you're going to have is to multiply 2 complex numbers. There's 2 different ways it could be offered. It might look like this. Negative 2 plus 7i times 8 minus 3i. Multiply like that, or it might be presented like this if you have 6 minus 3i squared. They're both handled the same way. You'll see what I mean. If I have a problem like this, you're going to FOIL it out. Remembering that when you get to the last 2 terms, that the answer is actually going to be real. Not imaginary, real, with an extra negative on it. So this is how it goes. You take this times this, so like FOILing, it's negative 16. This times this is positive 6i, and it's an I term because there's only one I involved in the multiplication. This is only one I term, and it's 56. But this one back here is actually positive 21. Do y'all see why that is? Do I need to go over it with you? Yeah? A lot of people will do this on this problem right here. They'll say, okay, this times this, that would be negative 21 I squared. But you have to understand by definition that that's a real number, negative 1. So this is not an imaginary term. These guys are. This is not. This is a real term. But this part of it is a negative 1, which changes the sign on your result. You good with that? Then to answer the question, now we're combining like terms again. This is real, and when we combine it, we get a 5. These are the 2 imaginaries. They got to be combined, and we get a 62. You okay on that? Now, to do this one right here, this is the way most of you will do it, which is perfectly fine. Show me your work. You write 6 minus 3i twice. And then you do to that what we did to that. It would be 36 minus 18i minus 18i minus 9. You see it? 36 minus 9 is 25, no, 27, right?
Mhm.
Yeah. And 18 and 18 is 36, so that one's done. If you're really, really good at foiling out binomials, it follows the same rules. Look, to FOIL a binomial without writing it twice, you would square what's in front. Take this times this, which is 18, times 2 in the middle, and square that, which is negative 9. And it gets you right to here, well, almost. That's the 36 in the middle. Should get you to that one as soon as you combine. So if you're really good at squaring binomials and you understand how to handle I squared, you'll be fine doing it just straight across, following the rules. Most people will do this to make sure that they're keeping track of everything one little bit at a time. That's fine. But both of those are a FOIL it out problem. When you get to the I term times the I term, it's real. Just has an extra negative on it. Okay, you ready to go on? The next problem, and there's only one, says find the discriminant of the quadratic and describe the number and type of solutions. Okay, so it will give you this quadratic equation like this, something like this. Yeah, that's okay. I'll leave it 29. Okay, and it'll have equal 0. And it says find the discriminant and describe the number and type of solutions. So we go, it would be to your advantage. If you're going to show me your work, which is a really good idea, is to write down what the discriminant is so that I know that you at least know what you're talking about. You get a point for just knowing what this is. So write it down. Then if you screw it up with the plugins, I can still give you credit for at least starting with the right thought. And then either below it or out to the side of it, you should write this. Okay, b squared. It's a negative number, but when you square it, it's positive. I get 49 there. And then I have negative minus 4 parentheses. That's my AC right there. And negative 2 times positive 29 is negative 58. Yeah? And then the arithmetic on that is 49 plus. You don't have to write this step if you don't want. You can grab your calculator and it'll calculate it with all the right signs and everything. It'll be great. Go to the home screen and we say 49 minus 4 parentheses negative 58. But this is a minus sign, an actual minus sign over here on the right as an operation. This is a negative sign. Make sure you get it straight. And you hit enter that and you get 281. So I can eliminate this line. So on the answer page for this problem, it's number 18, it'll say DISC blank, and then it will have another blank that starts past that, and this is going to be 281. And here you're going to write what? Two real solutions. Now, if this had been a negative number, then this AC product would have been positive 58. And now you're going to get a negative when you subtract. So we would do that problem. It would be 49 minus 4 parentheses 58, close it, and we get negative 183 in that case, in this case right here. So that's what you would write right here, negative 183. And what would you write here?
2.
Right, and you spell out the word IMAG. You can also spell this REAL if you want. But you can use a symbol too. But there is no symbol for imaginary numbers, so you write 2 IMAGSOL. Yeah? Okay. If it turns out to be 0, you write, what do you put here if it turns out to be 0? 0. What do you write here? 1.
So it's 0, so only that's a 1.
Yeah, and if you want to memorize it, that's fine. But there's a good reason for it. Look, In the quadratic formula, if you have this, which is what that discriminant would be, then your solution is only this because adding and subtracting 0 is nothing. There's only one, and it's real because B and A were real. Yeah? All right. Okay, so that's how you handle that one. The next problem just says graph. That's all it says, graph, and it's an inequality. So, it look like something like this. Let's say graph. This is number 19. And I'll offer you something like this. Y greater than -2 parenthesis x minus 7/2 squared plus 3/2. Yeah, you have to deal with fractions. Don't panic. In order to graph anything, whether it's an equation or an inequality, you have to know where to start, if it's a quadratic. You have to know where to start, which direction to count, and how to stretch or shrink it. Happily. And it's just like this on your test and on this thing here that gives it to you in this form. This is vertex form. If you know how to read it, if you can remember how to read it from chapter 2, you should be able to figure out what the vertex is just by looking at it. What's the vertex? What is it? 7/2, 3/2. And if that doesn't mean much to you as far as counting and locating on a graph, then you can write it in decimal form because this isn't part of the answer. However you want to write it to count it the best is fine. That's 3.5, and that's 1.5. That just helps you know how to count it on the graph. Will it open up or down? Down. How do you know?
-2.
The -2, the negative on the 2. Will it be shrunk or stretched or normal?
It will be stretched
By what?
at 2.
And one other thing we have to ask ourselves is when we actually draw the boundary, should it be dotted or solid?
It will be dotted.
That's just a little notation to yourself right here just to remind you that you need to dot it. Okay? And so we go about starting there, counting down every odd number times 2, our down count. Remember? Guess I'll put this over here. Okay, so I'm going to plot the point 3.5, 1.5. That's out 1, 2, 3.5, up 1.5, right smack in the middle of that box. And then I'm going to count down. Here's, I'm going to count it. I'm going to go out 1 to the middle of that box and not down 1. That's what I'd normally do, but I'm going to go down 2. Then I'm going to go out 1 again, and I'm not going to go down the next odd number, which is 3. I'm going to go down twice that, 6. Jump across, get some symmetry points over here like this. And then at first, I'm going to solid it because I draw solid lines more smoothly. And then I'm going to erase. You can do it however you want. Just make sure it's dotted when you're in your finished product. Then I have to finally look at this and decide how I want to graph it. This is how you read it. This is what I taught you to do. We want to graph those items or those y values which are more than, which is the same word as above, this graph. Do you see that? More than, above this graph which opens downward is this junk out here. And you don't have to indicate it with any more than those scribbles. Don't spend a lot of time coloring it in. I just want to know which of the spaces. Okay? I'm moving on unless you stop me. Everything good? Next one says, there's only 2 more problems. 24 and 25. And it says, graph the system of quadratic inequalities. So now you got a system to graph. Like this. And this is unfortunate, but it's not going to be in vertex form. So that means you're going to have to figure out some other way to graph it. If it's in standard form, you're going to have to remember the negative b over 2a to find the vertex. Or ask your buddy. He'll tell you where the vertex is. Okay, so system looks something like this. Graph the system of inequalities. It's going to be something like y less than or equal to 2x squared minus 5. And the other one might be y less than or equal to negative 4x squared. Well, I'm going to make it a 2 also. I really don't want to count down 4 that far. Okay. Negative 2x squared plus 3x plus 4. Okay, so it's presented something like that. For the sake of variety, I'm going to take one of those off. So, based on your knowledge of quadratics that you've been studying since the beginning of the year, can anybody tell how to graph this just by looking at it?
Yeah.
Where's the vertex? 0, negative 5. It's just going to go down 5. It's not moving right or left anywhere. It's just moving down 5, right? Okay. So by looking at that, not even identifying any of the stuff, hopefully you'll be able to say that's just the regular one moved down 5, and it's vertically stretched or shrunk. So we're going to start here, and it's vertically stretched by 2, and it's going to open up or down. Oh, why? Why up?
2 is not 2.
Yeah, because the leading coefficient is positive. Okay, so we're going to start down here at negative 5, because that's its vertical translation. And then we're going to go out 1, up, not 1, but 2. Out 1, not up 3. That'd be the next odd number, but twice that. Symmetry points. When I go to draw this, is it going to be dotted or not? Dotted or not? Solid. Okay, so I'll leave it. That's the first one. This one right here, you can either do negative b over 2a and plug it in to find the vertex. You can ask him. I'm going to ask him because he's quicker and more accurate. So I'm going to go to y equals, and I'm going to graph that thing as though it were an equation. So I'm going to write y equals negative 2x squared plus 3x plus 4. Standard screen. Ask it where the vertex is. So I'm going to go second, calc, a maximum. Like that on the calc button. A maximum, choose that. And we'll ask you for a left bound. You just need to be on the left side of the hill. Hit enter. Mine already was. Crawl over the top, start coming down the other side. Hit enter, don't guess. And I get 0.75 and 5.125. Is that what you get? Okay, so 0.75. This is the origin right there. 0.75 is 3/4 of the way out, and then up 5 and a little bit. 1, 2, 3, 4, 5, a little bit right there. And this thing's going to open up or down. Look at it.
Down.
Open up or down.
Down.
Down. Stretched or shrunk or normal. Stretched by 2. So it's going to count just like this guy did. We're going to go out 1, not down 1, but 2. Out 1, down 6. If I went out 1 more and down, how far would I go down? 10, but I'm not going to. Okay, jump across the axis of symmetry. Each dot that you plot is going to be located in the same location in the box, so don't get panicky about counting that. I'm going to go out 1 more and down here and match that up. And I'm going to draw my parabola like this. But should I make it solid, or should I leave it solid or dotted? Dotted. So we come back and erase a few things. Just sporadically, just so I can see that it's dotted. Then, we have to read it for shading. We want to be below the first one, which opened up with below the blue, because it's y's which are less than that graph below. We want to be below the pink, because it says y less than. We want to be below them both. Guess what that is? Right here. Weird. But that's where it is. We're below the pink, which means inside it. Because above would be out here. We're below the blue, which is outside it. Because the blue marker's right there, and below that is down here. So below both is this region here. Kind of weird, huh? But think about it, and you'll be able to find it.
So can you explain the shading one more time? Sorry.
We want to graph those things, and this is how I call, that's what I say about these are things. I want to graph that space, which is below these graphs. Below because less than and below are the same kind of word. You see it?
Yep.
Okay, so you'll have to graph that. Then, the last question wants you to use your grapher. It says solve the inequality, round decimal answers to the nearest hundred. This is that one where there's no y in the problem. There's no y, it's just x. But we're going to use a two-dimensional grid to answer questions about it along the x number line. Remember? Okay, so it's a situation something like this. You're supposed to find the regions and express them appropriately. Find the regions on the x-axis where this is true. Something like this. X squared. Hang on a minute. No, that's not right. X squared plus 10x plus 20. I don't know. Greater than or equal to 0. So what do you do? I don't think that's what I want. Because if you graph that, why don't you graph that? Because that's probably not a very good made-up problem. Graph that and see what you get. Oh yeah, it's okay. It's all right. I was afraid it wouldn't dip below the x-axis, but it does. It's 20 wasn't enough to push it up based on this. That's what I'm saying. That's what I was afraid would happen. But it's okay. You get something like this when you graph it. Okay, and it's all left of the x-axis. We want to figure out the x's that make the return value for plugging it in positive. Graph looks something like this. Just something like that, okay? Which values on here, based on what you're looking at, which values on here return positive values when you plug in those x's? There's three places. There's this one. We'll call that the left. Call this the right. And we'll call this the middle. Where do we find x's that make this true based on what you're looking at? The left and the right. Because any x value out here, if you find the y value that's going to go with it, or that the return value you get for plugging this value of x in, is up here on the graph, and it's positive, which is what we wanted, greater than 0. You see? Same thing over here. These don't work. If I plug that x value in, I get this for a y value, which is a negative number, makes this false. You okay? All right. So we've decided it's the outside ones. We just have to find out where these boundary numbers are so that we can reference them. So we go calculate 0. My cursor's slow, so hang on. Enter, enter, enter. My leftmost 0 is negative 7.24. Is that what you're getting if you round it to the 100th? So this guy right here is negative 7.24. Go find the other one. And I get negative 2.76. Do you agree? Now, since there are two regions split by something that doesn't work, since there are two regions that work, you need an or in between. So we say the answer to this is x's which are less than or equal to, being true to this sign right here, because there's an equal to on it, less than or equal to negative 7.24, or x's which are greater than or equal to negative 2.76. That's how you answer it in the answer blank. How would it be different if we did this little tiny subtle change? If we made it like that, what would you be writing? I'm going to make this change with red so you can see it's different from what we had before. That's the change I'm making. How will it change your answer? Now we're looking for values that are returned that are negative. And that's what we see here are negative return values right in between there. And this is how you answer it. This is where you trap something in between. X is more than or equal to this lower one. and at the same time, less than or equal to this upper one. That's how you would answer it in that case. Do you see it? How would it change if I made this a negative right here? It would flip this over and all answers get reversed. Because now the thing's up like this and positive answers are the bubble on the top instead of the bubble on the bottom. See what I mean? So you graph the thing and analyze it that way. It's not always going to be an upturned problem. It might be a downturned one. And you have to answer about positives and negatives above and below the x-axis. What do you think? You think you can? So remember, the deal is you're going to take it tomorrow, this practice test. I'm going to give you a key before you leave. You pick one up before you leave. Take it home. Study it over the weekend. Take the key. Look at what you got. If you missed it, go study it. I've got the answers worked out for you on the paper so that you can see how to do it. Compare it to yours. Learn from it. Get back here on Monday with any questions that you have on Monday. And Tuesday will be the test. Everything from this chapter has to be turned in before you get a test on Tuesday. And there are 7 assignments. 3.1. 3.2, we skipped 3.3, so 3.1, 3.2, 3.4, 3.5, 3.6. The written review that I gave you just before harvest, which is out of the book, and this practice test, which you will take tomorrow. 7 assignments, all due before Tuesday. Okay, hope you learned something from that. See you later, bye.